Now we are really getting into the trig aspect of this trigonometry, this intro to trig. So we're talking about our most basic trig functions. We have sine, cosine, and tangent. These are their actual names. Of course, on your calculator, how we write them, we do not write the whole name out. You usually see them written like this. No, you cannot call them sin, cos, and tan. That is ridiculous and makes you sound a little bit ridiculous also. So it is sine, it is cosine, and it is tangent. So when we are talking about sine, cosine, tangent, hopefully you recall SOHCAHTOA. If you don't remember it, have no fear, for we will go over it. If I want to find sine of theta, or if I am looking at my triangle here and I'm looking for sine of theta, you are always going to be doing the opposite side over the hypotenuse, okay? Or SOH, opposite over hypotenuse. And for this triangle specifically, I'm going to look at my angle and go, what side is opposite? And that is B. And then our hypotenuse is always opposite of our right angle. It's always our longest side, which in this case is C. For this example, sine of theta would be B over C. For cosine of theta, we are doing adjacent over hypotenuse. Okay, adjacent means next to. So if I'm looking at theta, the side that's right next to it is A, and my hypotenuse is still C. My hypotenuse hasn't changed. It will never change. Your hypotenuse will always be the same. And last but certainly not least is tangent of theta, which is always opposite over adjacent. Okay, TOA, T-O-A, opposite over adjacent. So I'm going to go for my opposite. What's opposite side is B. My adjacent side, what's right next to me, is A. So in this case, I would get B over A. So if I were to mix this up and I were to throw in some actual numbers in here. So instead of B, I have 8. Instead of C, I've got 17. Instead of A, I've got 15. Same exact process I'm going to go through. I have sine of theta. I need my opposite over my hypotenuse. I look what's opposite is 8 over my hypotenuse, which is 17. The sine of theta for this triangle would be 8 over 17. Cosine, I'm looking what's adjacent to theta, which in this case is 15, over my hypotenuse, which is still 17. And now for my last one, tangent. I already know my opposite is 8. I already know my adjacent is 15. Tangent of theta is 8 over 15. So you're just looking at the angles and those signs according to opposite, hypotenuse, and adjacent. Now, we are going to be using these basic trig functions and the properties of them, the SOHCAHTOA of it all, to find missing angles and missing sides. Before you can do this, on your graphing calculator, if you don't have one, you need to grab one. Pause the video, go get one. Get your graphing calculator. On there, next to the blue button where it says mode, you need to click on that button. Under there, it's the fourth one down. You need to make sure that degree is the one that is boxed and highlighted on your graphing calculator. If it is not, you're going to get some wonky numbers that do not match up with anything you think we should be talking about. Okay, so on this first one, we are looking for theta. So I need to figure out what is this angle. So I'm going to look at what I have. 12 is opposite of that angle, and 20 is the hypotenuse. So thinking about SOHCAHTOA, which of my trig functions uses both the opposite and the hypotenuse? And that would be my sine function. So I know sine of theta of that angle will equal 12 over 20. Now to solve for theta, we are going to use the opposite of sine, which is the inverse. So I'm going to do the sine inverse of my fraction, 12 over 20, and that will give me my value of theta. So if you find sine on your calculator, you'll see sine inverse is in blue, so you'll have to hit second, and then sine, and then put your fraction, 12 over 20, hit enter, and you will get theta equals 36.87 rounded degrees. All right. So if you have to find an angle, you have to use the inverse in order to find an angle. Now on this next problem, we're not looking for an angle. We are actually looking for a side length. So I am looking for x. Now I am given a degree. The other thing I am given right here is right next to it is an adjacent. Now if that is my adjacent, that means x over here is going to be my hypotenuse. I know it's my hypotenuse because it's exactly opposite my right angle. So if that's something you need to remember, your hypotenuse is always opposite your right angle. Okay? So if I know anything about my trig functions, the one that uses adjacent and hypotenuse is cosine. So the cosine of my angle, which is 28 degrees, so cosine of 28 is adjacent over hypotenuse. Now, this looks kind of wild, but we're actually going to solve it exactly how we would any other linear function. If I want to get rid of that x from my denominator, I'm going to multiply by x on both sides. So I have x cosine of 28 equals 22. Now cosine of 28, if I were to put that into my calculator, is just a large decimal. So even though it seems like a function, I'm going to treat it like it's its own number. So to get rid of it, like any other number, we are going to divide by cosine of 28. Letting those cancel. And now I have something I can put into my calculator. I can put 22 divided by cosine of 28, which gives me approximately 24.9, or our missing side in this scenario is 24.9. Okay. So using those trig functions and solving just like we would any regular equation. Now, sometimes instead of giving you a triangle, they're going to explain to you a triangle. So we have a triangle, DEF, where angle E is a right angle. We need to find F. If the measure of angle D is 62 degrees and E is 12. Now, some quick things to note about when we're talking about triangles and how we notate them. If it is capitalized, it's an angle. If it's lowercase, it's a side. And corresponding letters are always opposite. What that means, I know I've got a right triangle. Here's my right angle. I know that my right angle is angle E. It's capitalized, so E has to go there. The side that is opposite is its corresponding side. So if capital E is here, I'm going to go opposite, and lowercase e is opposite of that angle. My other ones we can kind of just fill in. So say this is D, D, and this is F. Now we just have to be careful of where we put our sides. If this is angle D, my opposite side is my lowercase d. This is angle F. My opposite side is lowercase f. And now I can fill in some other information. Measure of angle D, 62 degrees. And E is 12. Okay, we want to find F. So I'm going to look at what I have and figure out which trig function works the best. So here's my angle. We're talking about right here. I have my adjacent, so F is my adjacent, and E, it's opposite of my right angle, is my hypotenuse. Again, my trig function that uses adjacent and hypotenuse, think co is cosine. So I know I'm doing cosine of 62 is my adjacent, which we don't know yet, F, over my hypotenuse, which is 12. Now we're just solving like we would any other type of function. I need to get F by itself. To get rid of it divides by 12. We multiply by 12 on both sides. So I need to do 12 times cosine of 62, giving us F is approximately 5.6. Okay. Our three things over here are the important things that you need to know. It's capitalized, then it's an angle. Lowercase is a side length. Corresponding letters are always opposite. So I know if angle E is a right angle, then that side opposite has to be the hypotenuse. The last two review topics that we need to talk about are related to word problems. We're going to be talking about both the angle of elevation and the angle of depression. Now, for any of these story problems, I highly suggest drawing a picture every single time. It will make everything 10 times easier. So we have an airplane that takes off with an angle of elevation of 12 degrees and raises 1,500 feet. How far is the plane from the airport via ground distance? So we have our airport over here. Okay, there's our airport. And then we have our plane, right? Plane kind of looks like that. Now, my plane took off from the airport at an angle of elevation. So we have the ground. Having the ground is important. The angle of elevation, we're usually talking about the ground up. So this is our normal angle. We're starting at the ground. We're going up is 12 degrees. How much did my plane rise from the ground? Now we also know that the plane is 1,500 feet above the ground. We want to find the distance from the airport to the plane via the ground. So now that we have our image, it's just like what we were doing with the previous problems. I have my opposite and my adjacent, so I know I'm dealing with tangent of 12. And remember, tangent is TOA, so I'm doing opposite, which is our 1,500, over adjacent, which is x. And then we are solving just like we did in our previous examples. Using our calculator to plug everything in, we've got 1,500 divided by the tangent of 12 gives us approximately 7,056, let's go 0.95. Now, when we are talking about word problems, we have to use our units. If one side is recorded in feet, this is also talking about feet, okay? So when we're talking angle of elevation, we are always talking the angle from the ground up, okay? So think it's like a positive angle if we are graphing it on a coordinate plane. Angle of depression is different. So angle of depression is thinking line of sight and down. Okay, and it'll make sense when we talk about this problem and I show you the visual. Okay, you look out the window with an angle of depression of 32 degrees to see two kids fighting. You decide to break it up. Very good of you. If your window is 28 meters from the ground, how far away are the kids from that building? So once again, we're going to draw our picture. Here we have our building. Very nice. Maybe here's our window that you are looking out of. Whoop. At a person. Very cool. Now this is you looking at the kids over here who are fighting. Okay. You are looking at the kids fighting. The distance from you looking to the ground is 28 meters. And we want to find the distance from the kids to that. Now we were also given an angle of depression. Now, angle of depression. Currently, to see these kids, we have to look down. Our angle of depression is not this angle, okay? Our angle of depression is based on if I was looking straight ahead and how much I have decreased, okay? So this is our angle of depression, 32 degrees. If I was looking straight ahead and then I look down, that change is our angle of depression. Now, there's a couple of ways that you can go about this. One is talking about parallel lines. The ground is parallel to your line of sight if you're looking straight ahead. So if this angle is 32 degrees, then this angle is also 32 degrees. Okay. Or the way I thought about this is this total would be 90 degrees, which means I could do 90 minus 32 to figure out that this angle is 58 degrees. However you go about it, you'll get the same answer, okay? We're going to use that we have this 32 degrees in the corner. So if I am using this angle right here, I have to use an angle inside the triangle. I have my opposite and my adjacent. So again, I am using tangent. And tangent of 32 is my opposite, 28, over my adjacent, which I don't know what it is. And just like last time, we solve the same exact way. Multiply by x on both sides and solve for x. Divide by the tangent of 32, okay? We should get approximately 44.8. Now we could set the same thing up, say instead we use the 58 degrees. Again, we have, if I'm using 58 degrees, x is now my opposite, and 28 is now my adjacent. So I'm still doing a tangent function, but this time of 58, and my fraction is now x over 28. If you solve this the same way that you solved your last one, multiply by 28 on both sides, get x by itself, you get the same exact number, 44.8. So regardless of if you use your parallel lines cut by a transversal, or if you use supplementary angles to figure out what this angle is, you will get the correct answer either way. The biggest thing is angle of depression is you're starting from a perfectly horizontal line and you are looking at going down from it. Or really it's kind of a negative angle if you were to put it on a coordinate plane. So one way you can remember this is depression is negative, and so you got to think about you're starting at your origin side and you're going down, or you're going in the negative direction. Angle of elevation is you're starting at your original side and you're going up. Okay? Those are our two big ones. Good luck with your practice problems. You can come back to this video if you need some extra help.